Hi, and welcome to another episode of Raw Green, a show produced by OBI, your sustainability consultancy specializing in life cycle assessment, research, and green tech. Check us out at oneobi.com or connect with us on socials. Links are ready for you in the description. Ciao! I am Francesco De Lieto. I am passionate about sustainability and green technologies. Welcome back to a new episode of Raw Green. Last century, two gentlemen, Nikola Tesla and George Orwell, each imagined a world where energy could be transmitted wirelessly. One was a visionary inventor, the other a dystopian novelist. Fast forward to today, and two modern pioneers are turning that sci-fi dream into reality. And because sending energy through the air wasn't ambitious enough, they've decided to beam it down from space, tapping into the sun for a limitless, sustainable source of power. Our guests for today are Martin Soltau and Sam Adlen, co-CEOs of Space Solar, a high-tech startup based in the UK that's on track to achieve something extraordinary. Their project could radically transform the way we access and transmit energy, bringing us closer to a future once thought to belong only to science fiction. Martin, Sam, welcome to Raw Green and thank you for being here. How are you today?
Thanks, Francesco. Very good, thanks. Great to be
very well. Nice to see you.
Nice to see you too. And my very first question it is running a startup together as co-CEOs. Does it comes with couples therapy or just a shared calendars and lots of coffee?
Coffee is definitely good.
Yeah,
it's brilliant. I think we both couldn't speak more highly of it. I mean, it obviously depends on the individuals, but for Martin and I, we've got such complementary skill sets, so we can both cover the breadth of kind of business and technical, but we've got different strengths. We've worked together now for 5-6 years across different things, and it's always a pleasure. It makes that coffee in the morning all the more pleasurable. It being with Martin.
Nice. Martin, you're awkwardly silent. Do you confirm that?
Oh, completely, yes. I mean, space solar power is, let's say, an ambitious venture, and it needs a huge breadth of work across international collaboration, technology development, regulation, standards, it's space and energy. There's a huge breadth there. And the co-CEO model is absolutely fantastic. And I think it's probably essential. As Sam says, there's a real synergy between our two complementary skill sets. We work incredibly well together, and I think both of us say we probably couldn't do it without the other. It's really essential for us, and it is brilliant.
That's
Makes
wonderful
the journey
to hear.
great.
Yeah, that's wonderful to hear. That the complexities. I can only start to imagine the complexities that you guys have to go through every single day. Let's start from the very beginning. Some history, if you don't mind. How did everything started? So do you really woke up one morning and said, okay, Sam, okay, Martin, let's start to beam down solar energy from space? Or there was a moment, like a light bulb moment between you two?
We probably started about 7 years ago. I was leading the aerospace business for Fraser Nash Consultancy here in the UK, took the concept of space-based solar power to the government because they really weren't thinking about this sort of technology in the pathways to net zero, and became aware of just how incredibly difficult and challenging net zero is. And at the same time, being aware of space-based solar power becoming more viable, particularly economically, with the advent of reusable rockets, which then were starting to become operationalized with Falcon 9. And we ended up I directed a techno-economic study for the government on space-based solar power. It was quite a UK-focused study, and it was asking 4 questions. Is this technically viable, economically viable? Could it be commercialized in time to really have an impact for the UK in the net zero pathways? and finally, what are the economic benefits for the UK? So it's quite a UK kind of centric study. And the answer to those 4 questions was a really, really positive yes.
Sound yes.
It was we pulled in a number of partners into that study, including the Satellite Applications Catapult. Sam and I got together shortly thereafter and established the Space Energy Initiative. And I'll let Sam take over the story from that point of view.
Thanks, Martin. Yeah, so I was at the Satellite Applications Catapult, and in parallel to Martin doing the study, the Satellite Applications Catapult's always been about, it's an innovation centre in the UK focused on space, but particularly what space can do for Earth and the economic benefits that can be delivered by space. So again, similar thoughts, noticing the step change that's about to happen in terms of cost and capacity of launch, and that concepts like space solar power, which can really have a hugely positive impact on Earth, suddenly become economically viable. So as Martin says, we set up this thing called the Space Energy Initiative. It's now a coalition of the willing, of more than 90 organizations across energy and space and government in the UK, really coming together to make space-based solar power a reality. And we did it because we recognize that typically you do a study for government, and the most likely next step would be maybe another study if you're lucky. So we wanted to set up the ecosystem, the environment, and we've successfully done that now. It's really raised the profile of space-based solar power globally. And then we recognised that through our chief architect, we had the class-leading space-based solar power design, and that's what then led us to set up Space Solar, and we incorporated back in 2022 and making some really great progress.
Yeah, as part of the Space Energy Initiative's impact, I mean, the government put space-based solar power into the National Space Strategy. They launched the Space-based Solar Power Innovation Programme, put about 10 or 11 million pounds into it. So and we've had the government launch a regulatory body called the Space-based Solar Power Legal and Standards body. So this is advancing the regulations around space-based solar power. So it's had huge impact.
I can imagine. And it's not just for net zero, it is for energy security, especially in, say, the current circumstances we're living on, which are completely mind-blowing. I mean, they're irrational. So yeah, makes total sense. So you say that the thing that makes space solar economically viable, that, let's say, 10, 20 years ago didn't exist. It is the rocket launch, the transportation part into space. What about the technological side? For example, the beaming. Which one of the two, for example, you would say because of this we are now able to develop the extraordinary thing that we want to develop?
Yeah, it's a combination of things. So the economics is central to this, but the advancing development of power beaming, robotics, lightweight photovoltaics, high efficiency photovoltaics, these have all been really important technologies. I think AI is going to play an important role as well. So it's this combination. And I think then at a systems level, the development of concepts like Cassiopeia, the solar power satellite, which is a hypermodular design, is also core to the economics, because hypermodularity allows you to really reduce the unit production costs. And that's a big part of this.
Yeah. That building up that skill economy. And talking about, let's say, techno economics, okay. Let's say if you want to do an initial comparison between the space solar and the Earth based solar, how does it stack up towards not just solar but also other terrestrial renewables in terms of long-term cost, efficiency, reliability, levelized cost of energy? I mean, the full package.
Yeah, so there's a couple of answers to that. If you look at the technologies in isolation, space-based solar power has really all of the characteristics you'd want in an energy technology. It provides baseload, continuous all-weather, reliable power. It provides dispatchability. That is, it can be tailored second by second to balance the grid, which is a really important part of this. It provides export without fixed interconnectors, so it's a transmission system wirelessly as well as, and it's got very good environmental impact, very low, comparable with wind and solar, orders of magnitude less mining and minerals used per kilowatt hour, and then finally it's viable. It's one downside, if you were, is it doesn't yet exist. It needs a development program. The second way of looking at this is the whole energy system, because low energy density and weather dependent wind and solar impose huge costs onto the whole energy system. They need backup from either storage, which doesn't yet exist, or other forms of baseload like gas, and so the whole energy you also need to build out the grid hugely, the transmission system, to connect up wind in the North Sea with where it's being consumed. All of these things add hugely to the overall energy system, and there have been independent studies that show that space-based solar power dramatically reduces the cost of the whole energy system. Imperial College have studied this with a very complex whole energy systems model. If you put in just 8 gigawatts of space-based solar power into the UK energy mix, it delivers savings of over £4 billion every year. And it just shows wind and solar are not cheap because of this need for duplicated sources of backup and baseload.
Well, yes, let's say the back end and the transmission part, it is something that it is a major constraint. I mean, project development costs now, which include the grid connection, have reached a level never heard before, not to mention waiting time to get connected to the grid. But my question is, what is the scale that space solar need to reach to be able to create also redundancies? Because if you put 2 gigawatts in space, that it is not going to be enough also to let's say have that security to say I have 100% guaranteed baseload energy.
Yeah, so I mean our plan as Space Solar sees us delivering 15 gigawatts a year by the mid 2040s and scaling from there. And it's the scalability that's really one of the attractions of space-based solar power. So our CTO actually came from the world of fusion. He was engineer in charge at the Joint European Torus, which was the world's biggest fusion experiment. He very much believes that fusion will work. Like everyone, believes it's hugely important. But what he's not so sure about, and why he's so keen on space solar power, is A, the scalability, and B, the sort of end of a kind unit economics. Do they drop down, or do they stay sort of fairly flat or even increase like nuclear fission? And so if we really want to impact net zero and energy security, the scalability is hugely important. And space solar power, it offers this huge flexibility. We're actually sizing systems so that, about 600 megawatts at the moment, so that you've got that
modularity.
Yeah. And the other thing is, if a system goes down, it's 6 months to a year to put another one up. It's not a decade.
Wow. That's faster than fission nuclear, way faster.
100%. Just to go back to your kind of earlier question on comparison, one of the things that gets thrown at us very regularly initially is, well, don't we just need solar and batteries? I mean, that's going to solve everything. But you can do some very quick back-of-the-envelope calculations just to show how compelling space-based solar power is. I mean, you use a lot less materials because you don't need the structure up in space. And then you don't need to overbuild, and you don't need batteries. You need a very, very limited number of batteries, limited amount of batteries for our smaller systems, which aren't quite continuous. Do that, and then you offset it against the cost of launch. And even with very conservative launch cost assumptions, you're comparable with terrestrial solar in ideal conditions, but baseload, which is great. If you look at the solar power plant that was just signed off in the UAE a few weeks ago. It's a gigawatt of nominal baseload. It required 5 gigawatts of solar power, of solar panels, and 19 gigawatt hours of battery storage. And comes in at about $6 billion for that 1 gigawatt. So it's not that much better than some of the existing nuclear stuff. So, and that's in ideal conditions. So, we really have a challenge ahead of us. We hope it all goes in good directions. We need all of this stuff, but space-based solar power adds a really important sort of flexibility into the mix.
But you need also that diversification in energy generation, nonetheless.
Exactly.
So
100%.
It doesn't matter. You cannot always put. You can only put your eggs in one basket. I mean, first thing that they teach you when you do anything.
Exactly.
What about the tech? Let's talk for a second about the tech. For us normal people without 11 PhDs like you guys have, with a very limited knowledge of physics, how do you convert the electricity into a beam? And how exactly do you concentrate that beam from space on Earth without deep frying a village? What's the transmission method? How safe it is?
Yeah, this is not new technology. This is just like a phased array radar, which we've been doing for decades. So you convert the sun's energy into electricity just by space-rated photovoltaic panels, just like we have here on Earth or on satellites already today. Then the electricity gets converted into high-frequency radio waves at 5.8 gigahertz. That's done with RF power amplifiers available today, and you form this large transmitting aperture. So the core of the solar power satellite is the small one's about 400 meters in diameter, and that forms this large array of antennas, which together makes a large transmitter, and it forms a coherent collimated beam. You adjust the phase of each of the antennas just like a phased array, and it forms a coherent collimated beam of energy down to the ground-based receiver. It's what we do with radars on ships and aircraft today. It's slightly different in that space solar has novel technology with a 3-dimensional phased array. We can steer the beam through 360 degrees without any moving parts. And that's essential because as the satellite goes round in the orbit, it's got to continuously look at the sun, and it's got to continuously point the beam at the ground rectangle on Earth. So we have this unfair advantage, as it were. We have a much smaller satellite, and it can provide this baseload with no moving parts. And then at the end, on the ground receiver, it's a rectifying antenna with these little dipoles that convert the
back.
Yep, back into electricity very, very efficiently, nearly 90% efficient. This is today's technology. It's been demonstrated multiple times, right back to the
whole
1970s.
The whole turnaround efficiency is 90%.
So the conversion at the ground receiver from the RF to the electricity is about 90%. From the DC electricity on the satellite to the DC coming out of the receiver, it's about 50%.
Okay, which is
total, which is
very
still
good.
Really good. Yeah. And it's 100% utilization. That's the difference. If you put this solar panel in space compared to a solar panel on Earth, you're generating about 13 times the amount of energy. And this really underpins the economics of space solar power.
Wow. What about heat though? Because I mean, even solar, it generates, even a solar panel on a rooftop or in a desert, it generates heat.
Yeah.
What about the beaming down? Will I be able to cook potatoes while put on the beam, or is it something that it goes dispersed all the way down to Earth?
Yeah, it doesn't interact with the atmosphere at all. It doesn't cause any heating of the atmosphere, and it's low density. So the peak of the microwave beam is about 230 watts per square meter. That's about a quarter of the intensity of the midday sun at noon. So it's not going to cause any sort of heating effect that might be disruptive. The reason we choose this is it can be regulated with today's regulations. At the edge of the rectifying antenna, it's less than 10 watts per square meter, which is the limit for sort of indefinite public exposure to to this. As I say, it's just a very, very mild warming effect. So this has been chosen because it can be regulated and because it's safe, and for interoperability with aviation. It's well below the standard certification limits for civil and military aircraft.
Okay. Well, because how wide are we talking about? Is this beam going to be?
It's between 1 and 4 kilometers in diameter.
Wow.
So it's a large area, low density, and that's why it's safe. That's why we choose it.
You briefly mentioned a few minutes ago about space. Okay. How big it is, first, and second, how do you manage? I mean, I keep hearing about it, space junk. How are you going to manage what could possibly be a risk of the project in the space debris that are going to damage the system in space?
Yeah, so the systems in space size from 400 meters diameter for a 30 megawatt system up to about 1.5 kilometers. We've got a slightly smaller system that we can put in a low Earth orbit that does power for the poles. So that'd be a few hundred meters diameter. Now, space sustainability is as important as sustainability on Earth. I mean, one of the things we've been very, very clear on from the start is it's got a holistic program, addresses all the key risks. It's got to be kind of net positive in all areas. And space sustainability is key. So people recognize that orbits now are becoming crowded. It is very big up there. We should
There's
have
a little bit of space.
Yeah, there's a little bit of space up there. The crowded orbits are typically low Earth orbit. So we use mainly highly elliptical orbits and a geosynchronous orbit. So we're avoiding the orbits where there are lots of satellites. But debris itself is an issue, and sustainability is an issue. So the systems are super lightweight. They're flexible systems. They're thin. Their shape is maintained in space. But from a debris perspective, it's like throwing a stone through paper or cardboard. It tears rather than, say, through glass. So you're not shattering. You're not creating debris if there is an issue. And that's where this hypermodularity comes into play. So again, they're comprised of hundreds of thousands of the same coffee table size modules. If one of them degrades or becomes defunct, then the other 99.999% carry on going. And then we have a sort of continual upgrade process. More broadly on sustainability, it's fair to say that the way we use space today is daft. We've got this huge asset. We've got this huge asset up there, and the modus operandi, the sort of paradigm in space, because we've been kind of mass constrained, is that you launch things to be as far apart from each other as possible, which is bonkers. You think about kids in a playroom. You try and clear it up if everything's scattered around everywhere. It's impossible. You want your stuff all together. Mm-hmm. And if you think about how everything from the microscopic to the macroscopic actually evolves, it evolves as clusters and connections between clusters. And so whilst there are good things going on in space sustainability, and it's very much recognized as an issue, we need to be really careful not to continue with what is a really silly paradigm at the moment. So just saying you can launch stuff as long as it comes and burns up into the atmosphere and causes environmental issues in the atmosphere is not sensible. What we need to do is get good at space. So we need assets in space that can move around, co-locate with each other, and have these clusters. And that's what doing something like space-based solar power drives you towards, because you end up getting good at space because you're building these hypermodular systems where innovation's a numbers game. You practice, you actually get good at space. You have all of your assets together in one area, and then you can drive this circular economy in space. So it's actually the sort of thing that makes it sustainable. So one of the things we need to do is actually move the way people think about space and the way we operate in space, because it's basic economics, that the economics of sustainability will only work, firstly, if we're good at space and can move stuff around, and secondly, if all your stuff's relatively close to each other.
You raised a very complex point, though, which is you talk about modus operandi, and there is something where there is an entire literature that needs to be generated from scratch. And I'm talking about the regulatory ones. I mean, and you're not just working, let's say, like a, I don't know, wind farm offshore that you have to deal with n number of regulatory bodies, IMO, whatever others. Here we're talking about a wild west that still needs to be heavily regulated. So who gives you a permission, for example? Who gives you a building permit to put 2 gigawatts and beam it down into space? How does that work? Or we let's say have to make rules as we go, as we move forward through the roadmap. Yeah. How does it work?
You're right. The regulation is a really important part of this, and it's something we've been very strongly engaged with. It's energy and space, so there are multiple regulators, and we've been establishing and working very closely both with the national regulators, that's Ofcom, who manage spectrum in the UK, the CAA, Civil Aviation Authority, the UK Space Agency, Department for Transport, and then internationally it's the International Telecoms Union. And so we've been developing the regulation roadmap with the regulators. They've been super constructive and supportive, really proactive. I've been blown away by how good the
That's great to hear.
Have been. I guess it's an exciting new area for regulation, but I think the reassuring thing is that we're looking at developing these regulations within the existing framework. So for our early development and demonstration systems, that this is going to be regulated just in the normal processes that you have for filing satellites, getting slots, confirming spectrum, confirming our sustainable approach to the mission, and all the rest of it. For the ground segment, we're really closely engaged with Ofgem, which is the energy regulator here in the UK, with the Crown Estates, who manage the coastal areas. We envisage our early systems being offshore, and with NESO, the National Energy Systems Operator. So that's the part of the national grid that operates the whole grid and oversees its stability and things. Again, really supportive, constructive, and positive engagement and dialogue. And then we've got
international
really
level.
Strong. Well, yes, indeed. So internationally, we've got agreements with energy companies. Reykjavik Energy have been fantastic, and so we're developing pilot projects with Reykjavik Energy and others, and that's all about the licensing and permitting at grid integration for the early systems.
That's where we go back to that international cooperation you mentioned earlier. It's needed because there is that energy security part that I mentioned earlier, which obviously it is not just a national level, but it is a geopolitical level. So this obviously can have your technology, what you guys are trying to achieve can have a huge impact on national energy independence. But at the same time, at 180, what about the global energy politics? Can it reduce conflicts over resources or spark new ones? Again, we are no man's land or space in this case. So what's your point on this?
It should end up being very positive. So I think Martin touched on the fact that you can use a lot less key minerals, so rare earths. You can use up to 8,000 times less rare earths. So that should be helpful. That's from a kind of international from the perspective of international issues. Then Martin also touched on the fact that just within the UK, because of this ability to flexibly switch the beam between points of demand, wherever you want to switch it to, there's the system cost just in the UK. If you do that internationally, if you optimize the energy grid internationally, then you've got the export potential and reducing the system costs internationally. The benefits are absolutely huge. So you'd like to think that sharing energy between nations, much like trading between nations, actually brings nations together, makes the global cooperation stronger, and that's certainly the angle that we're keen to push. It's also got incredible prospects for democratizing energy access, because your expensive assets up in space and you've got relatively low cost rectenna. It's not quite the same as a GPS satellite and just having a phone, but it's that sort of principle. So it has huge potential then for how it can help in all sorts of different aspects of global energy security.
That's very good. That's very good to hear. Yeah,
we're working with the sort of African entities and energy companies, and this is really going to democratize energy access to affordable, abundant energy for those developing nations where the demographics are growing rapidly. They urgently need more affordable energy, and that's not going to come from wind and solar.
I couldn't help but think about the complexities that, the limitless number of complexities that you guys have to go through, and the parallel with fusion. Okay, let me give you an example. What's stopping, for example, or maybe you already thought about it, that across all the technology that you have to develop, because we're talking about multiple technologies to put together here, exactly like fusion, there would be a breakthrough in a particular part of the technology that would basically deviate attention to the big target. Let me give you an example here. There is a company called, I don't know if you heard of it, Quaise Energy. The researchers on Quaise Energy, for what I could gather, if I remember correctly, they were working on a fusion project. And they realized the potential into the plasma containment system to be able, not dissimilar to what the beaming technology is doing, to channel that plasma management into creating a very high efficiency drilling technology to be able to access geothermal at very deep, a very large depth, high deep, like over 12 kilometers, which makes basically geothermal energy accessible for any parts of the world. Sorry, I'm getting too excited about this thing. So I think about your beaming technology. Okay, what's stopping, for example, to use that beaming technology on Earth and say, okay, we have developed something that we can still democratize energy by just using the beaming technology without the need of sending stuff up into the space?
Can I beg to differ on your comparison with fusion?
Please.
So what we're doing is taking today's technology and integrating it into a very innovative new system, space-based solar power, and the challenge we have is about engineering the economics of that so that the whole system provides affordable. What we're not doing is developing cutting-edge new technology which needs brand new physics, and we don't really know how to do that yet. And that's why space-based solar power is going to be a thing decades before fusion, and it can scale up much more rapidly and all the rest of it. On why we can't, well, can we use our beaming technology on Earth? Yes, there are a number of use cases, and this is going to be really important for the economic journey and for developing early markets and returns as a commercial company. But Sam,
yeah, I think the way you talked about fusion is quite interesting. I mean, there are definitely parallels in terms of the way the ecosystems are developing. So with fusion, it was backed as large government programs, and then you've got this sort of startup ecosystem. But actually, the way the startup ecosystem is being funded by the investors is, yes, there's one or two that will have concepts that turn into fusion power plants, but there's actually many of them that are actually focused on specific bits of the components of the technology, like the magnets or something that, yes, they have uses in fusion, they have usage outside of fusion. So that's what's working for investors. You could see that could, the space solar power world could evolve like that as well. We're seeing quite a lot of investment now coming into the sector. We had company Etherflux raised 50 million last week.
That's from concept. The Robinhood co-founder guy.
That's
him?
Right. Yeah, exactly. Yeah. So, it feels like the conviction from the investment community is growing, and that'd be interesting to see how that then gets applied. But for us, one of the beautiful things about our roadmap is what we create on the journey. So we powering drones. We've got terrestrial uses of power beaming. We're creating large structures in space. So we've got large lightweight arrays of solar panels that powers the next big constraint in space that could power next generation of SATCOMs, of data centers in space. These are all huge adjacent opportunities that make it a very investable and value-creating roadmap we've got on our journey.
That was one of my questions. What is, I mean, as of today, in any clean technology, the funding and investment landscape, I can tell you for a fact, it is a really tough one. But is it venture capital? Do you see with Etherflux, but besides Etherflux, do you see, let's say, the venture capital getting more excited about space solar, or is still government support the main driver?
No, it's definitely seeing private interest now. Government support's really important from a range of perspectives, regulation, finance, users. But there's 3 or 4 companies already been funded. So Overview Energy, Reflect Orbital, and Etherflux. So Overview and Etherflux are laser-based concepts. They have smaller systems because you've got a higher power density. So great uses in certain applications, particularly defense, for example, but not so strong for really impacting on energy security and net zero because of atmospheric absorption, your conversion losses, and the fact that, you know, if you want to beam megawatts or gigawatts, then that is in chicken frying territory. So. But it's good to see the money now coming in, and also a real switch, and people are recognizing that large infrastructure in space is now, you know, there's a few kind of investor notes around about that now. So things are changing rapidly. For us, with our microwave systems, you end up with bigger systems, but what we create on the journey. The fact that we've got these systems that can be launched in different orbits, we have smaller satellites, makes for a very financeable roadmap now. And we're looking forward to working with partners that want to come on the journey.
What about other countries? I mean, we know the UK government, it has the mindset to work on stuff like this. It's still moving on with the net zero targets. It has been actually the first country in the world to set up net zero targets. But I know, for example, the US is back to the future with coal, a fantastic and clean form of energy, very futuristic. What about other countries? China, for example, do they have similar programs and projects in their pipeline, or Russia, for that matter?
Yeah, they do. We're quite closely engaged with all of the international players. Japan is probably stand out. They've got a really, really good long-term policy-based program of technology research and demonstration. They're launching a small-scale mission probably early next year. Wow. China again has got a very, very long-term, very focused mission. They're looking at kilometer-scale systems in space later this decade, and then the US military are very, very strongly focused on this, mainly from the perspective of providing energy security and operational independence to
missions,
deployed operations. Exactly, yeah. So they've got a lot of research and technology on deployed structures in space and power beaming, but not I think none of those have got the concepts that are ultimately going to be providing economic energy. So it's not super easy to come up with a system concept that is low mass, high specific power, provides that continuous base load, ability to continuously look at the sun and continuously power the rectenna. And so there's quite a high barrier that Space Solar has created with our patent protected IP and design. Other nations, I think, are very, very interested. So South Korea has got a really good program, and then, as Sam says, there's a number of startups which are gaining traction. So this is rapidly becoming a next generation energy technology that all countries are looking at very seriously indeed.
What about you? What about Space Solar roadmap? Are you going to go into fundraising anytime soon? Are you already in fundraising? What is the, let's say, first I know the long term. goal, but what about the short-term roadmap?
Yeah, so we're raising a seed round at the moment. We've predominantly been grant funded to date and made some great progress. I mean, we've got we're at concept maturity level 4, so we've got a full subsystem level design that we know is producing really economic power. So we know we can build this, which gives us great confidence. So we go from the other two things we've got. We've got a half-meter demonstrator of this core 360-degree power beaming technology.
Nice.
And we demonstrated last week some of our assembly robots that build the global structure for the satellites, which is brilliant. So things are moving in a fantastic direction. We go ground to air power beaming, so long distance, high efficiency power beaming in 18 months, a demonstration at kilowatt scale in space in 3 years, alongside an assembly demonstration, and then a first 30 megawatt system in 5 years' time is the plan. We're raising a seed round at the moment, and excited to be the prospect of working with investors that really buy into the vision, the journey, and want a high impact, high optionality, high return venture to partner with.
That is a very good point, Sam. You need, I mean, having the right investor is like finding the right wife. You need that commitment, because we're talking about a long-term vision. I mean, to create something absolutely extraordinary and new in so many different perspectives. Which we listed some of them, not all of them, because this is just scratching the surface of everything that you guys are working on. And now the long-term vision, though. So in 30 years, let's say, still the Hinkley Point 2C still has to be finished, but what you guys in theory should be already with 2 gigawatts up in space. Sorry. But the time frame of building nuclear power plants, I don't know if my kids or the kids of my kids are going to see that done. You still have in 30 years, let's say, already 2 gigawatts in space. What's going to happen? How do you envision it's going to be the situation in 30 years?
It'll be much quicker than that. So Sam says, within 5 years we'll have our first commercial system. By the mid 2040s, in 20 years' time, we'll have 15 gigawatts commissioned and deployed, and we'll be scaling up at 10 gigawatts a year. So this is the power of hypermodularity and gigawatts, gigascale factories and doing this sort of thing. It's completely unlike monolithic power stations that you have to build from scratch. So I think in 30 years' time, we really genuinely see space-based solar power, and not just space solar, other players as well, have made space-based solar power a major part of global energy production, and it will be to lay people who haven't followed space or energy particularly closely, they're just worried about their energy bills. It'll be like this brand new thing coming out of nowhere, suddenly being a thing. We do a lot of conversation with the public in different ways, and there's a lot of excitement and support about this in the media and things. But we need to continue that, because it's we need, with any new technology, to get strong public engagement and support.
Buy-in. That was one of my questions. Exactly. How do you convince the public to buy in into something complex and, let's say, visionary like that, and also convince them that this isn't just, I don't know, a Bond's villain plot that can be weaponized while producing energy at the same time. So there'll be a lot of communication, education here, work to be done, I assume.
Oh, sorry. After you, Martin, you go.
Yeah, yes, there is, but actually, what we've found, and we've been engaged with structured public outreach through organisations like the Royal Society, who've going to pull together 120 members of the public for a really good structured dialogue. And we found that actually, because space-based solar power isn't building horrible industrial infrastructure in people's backyards, these rectennas are going to be offshore. They're not like, they haven't got mobile phone masts next to people's houses and things. And combined with the fact that this is going to provide reliable, much cheaper energy. And so this has been, we've found really positive conversations with the public, and because the government has got behind it, and is backing this increasingly strongly, and there's increasing media, very positive media conversations. I must say we've been really pleasantly surprised. Most of the question marks are about its viability. Skeptics who haven't sort of engaged and don't understand why it could be economically viable, rather than everybody knows, particularly in the UK, that we need cheaper forms of energy. We have the highest energy costs almost anywhere in the world.
Yeah. I mean, one of the nice things about the people we engage with, energy system experts, people who really understand the energy system, absolutely love this. They really get how this can be such an important part of the future energy mix, and that public dialogue's really, really key. But there are lots of benefits to people, to stakeholders that might want actually to have a rectenna on their land in the future, because you can still grow crops, you can still have a solar farm underneath this thing. It's a transparent mesh, and then we're using the same frequency as Wi-Fi. It's stuff that people are walking around in every day.
Look, when I told you when we met, when I heard about space solar, I jumped like a happy toddler, and I'm seriously considering to call in this episode clean tech porn. I told you this the first time. I'm not sure if I will do it, but it should seriously be categorized as clean tech porn, because it is absolutely incredible. It really is. Look, Martin, Sam, please go on.
I was just going to say that we work very closely with a number of the leading universities here, and many of them are changing the focus of their modules to include space-based solar power, both in next generation photovoltaics or power beaming and robotics and things. It's really commanding huge excitement with the next generation of engineers and scientists. I can
imagine. It's from every perspective. The energy transmission. We're talking about material science here involved. We're talking about robotics. We're talking about energy generation. We're talking about physics in space, transportation, logistic. I mean, guys.
Yeah, and so combined with such a sort of important societal need.
Yeah, exactly.
But as you say, the economic case just for going on the journey is fantastic. The work that Martin did all those years ago, it's 143,000 high value job years through the development program, and you create these future industries. We need these future industries for our kids, and an exciting, bright future, and that's exactly what space-based solar power can bring.
Yeah, and in contrary to nuclear fusion, you don't have that "not in my backyard" issue. So because it's really, really far away. So it's again, there are so many positive sides. I'm pretty sure you guys are going to have a lot to work through. I wish you all the best with your fundraising efforts. Anybody who's listening to this, reach out like now. And I thank you very much for your precious time. This was phenomenal to hear from you what you're trying to achieve. You and your team are trying to achieve, and I very much look forward catching up with you soon to hear about your progress.
Thanks very much, Francesco. It's been a delight.
Yeah, likewise.
Ciao. I'll talk to you soon.
Ciao.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!